about to find out.
So what we're going to do here today is we're working on a 2014 Coyote cylinder block. The Coyote cylinder block was introduced back in late 2010, and we were fortunate enough to get our hands on one of the first ones before they were even in a Mustang. So we were able to do research and development for quite some time. So we were learning the weakness points of this block during that time. You know, of course, you know, the crankshaft's real good because Ford puts a forged crankshaft in it. The block, it showed signs of promise at that time. The rods and pistons, of course, are all powdered metal and cast material. They're not going to hold up to any kind of power. So basically back in 2011, 2012, we were just doing rods and pistons, and everything was, people were making, I mean, these engines make exuberant amount of power fairly quickly with just a power adder, a blower turbo, or nitrous. So as we got more familiar with the engine, we realized that the breaking point was the block. No matter what we did, the block was going to break. We tried doing billet supports, and they worked to a point, but they ended up either leaking water or totally cracking the block. So what happens is it breaks at a point where the water jacket and the cylinder meet. It's very thin up there, and that's where the combustion takes place, and it'll crack it and fold it over. Next thing you know, you get water in the cylinder, whatever. So I want to say it was 2013, 2014 is when Steve DiMagirian from Race Engine Development said, hey, we're going to adapt some of our mod motor sleeves to this Coyote block. Now, the good thing about the Coyote block, it shares all the dimensions as the mod motor 4.6 block. Bore spacing, deck height, main bore size is all the same. So by doing that, he was able to go ahead and have his design already done for the Coyote. We just had to fit it into the block. So Steve has been an intricate part of the dart and sleeve program for the Coyote blocks and all the mod motors for years. He's come up with ideas that are just like, wow, how did you think of that? And it's just crazy. After we got with Darton and Steve over the years, we were actually having Steve do a lot of the sleeve work for us at the time because we didn't have a machine that was capable of doing it to tolerance. The boring bars and everything else around town and what we had couldn't get the job done the way we wanted to do it. So Steve was doing it for a few years. So finally we were doing so many of them, it was time. I got with my Rottler sales rep and said, listen, it's time. We need to get a block machining center. We need to do something where we can keep this in-house because we're doing so many. I can't afford to keep sending it to California to have these things done. You know, not only that, I'm working on somebody else's time frame because he's busy not with our stuff but with other stuff. So at that time, it was time to do the Rottler F69. Coyote block probably dominates this machine right now as far as when we're doing sleeving. I would say 80% of the time it's cutting sleeves for the mod motor platform or the Coyote platform. And as we do that, we've learned how to do it faster, more precise, and keep a product in here that's going to last for several years. And we got Coyote engines making over 2,000 horsepower with the factory block and only dart sleeves. So that just attributes the capabilities of having a precision machine to make sure that you have that product you can give the customer that's going to make that power and be reliable. What we have here is the dart sleeve that we're going to install. This dart sleeve has been around for quite some time. As you can see, it is quite an intricate piece. It is a flange type sleeve which has two pieces to it, two parts to it. It has the OD where the sleeve slides in, and then it has the top part which is in another OD which is a step. Now this step in the aluminum block keeps it from sinking down. Now that's what we need in these aluminum blocks, because we all know aluminum blocks, the heat dissipation is incredible and it just wants to expand, and you get that sleeve drop. No matter what, even if you have a step, and it's kind of hard on some of these blocks because it doesn't really have a place to step the bottom of that sleeve. So the top flange piece kind of interlocks in two ways. Number one, it goes down, locks in, then when the head goes on it, that thing's not going up and down. It's not going to move. So that makes it the best choice for any aluminum block. Now on this sleeve here, it's quite a bit thicker. It's 250 thousandths thick compared to the factory sleeve on the Coyote, which is 60 thousandths thick. So you can see we're giving it the meat where it needs to be, especially on the top half of it. That flange sleeve is pretty much on the top piece of it, gives you that bulk and effort where it's not going to pull over, because the combustion is taking place on there. Where the factory blocks will crack in that area, it's just going to pull it over and crack it, where that's not going to happen because you have all that beef right there. So the Rottler machine, its repeatability is second to none. I can put that cutter in there and make the cut, and it's going to repeat it every single time. So the first step in the Coyote block is we have to do our OD of the sleeve. It's quite a bit bigger. It's 3/825. A standard sleeve, so this sleeve is probably about 250 thousandths thick, where a standard sleeve is only 60 thousandths thick. So this is quite a big, beefier sleeve, hands down. So once we get that to size, we have to cut the top flange piece. So what we do is we use the circular interpolation feature of the Rottler F69 to actually cut that relief for the top. And the circular interpolation function, it has been great. Probably over 100 sleeve jobs a year on this machine with Darton and the Rottler tooling. And Darton, their precision on getting us a sleeve that actually we don't have to adjust the tooling every time we get a set is awesome. And not having to adjust the tools every time from Rottler makes it a faster process, where my guys are on the machines and they know they can pretty much set the tool in it and forget it. As a machine shop owner, time is money. So as we take this stock block and we put rods and pistons in it, it's only good for around 900 wheel horsepower. That's about it before we start having issues. And I always tell my customers, hey, it's not a matter of if, it's when it's going to happen. So if they're looking to a point to go over that certain amount of horsepower, then they really need to determine if they want to do the dart and sleeves or they want to kind of back down the horsepower. Now as we do the dart and sleeves, that particular block goes from 900 wheel horsepower to we have guys making over 2,000 horsepower on a factory production block from Ford. That just makes it amazing on how efficient these motors actually are and how much power they can handle after you put the right aftermarket components in this block in order to make that kind of power. Now, in order to do that, we need a precision machine to do that. So that's why we chose the Rottler F69. Every time we put a block in there and we machine it for the dart and sleeves, we know that that block is going to come out the same every single time we put in the machine because that's how accurate this machine is. My guys know that when they grab the tooling for it, it's going to be dead on every single time, and it's going to be repeatable. Every time we tell that machine to move, it's going to move to exactly where we tell it to every single time.
We updated to the Rottler F69A block machine, which allowed us to deck and bore blocks, you know, within an hour, taking your time. And you can clearance for rotating assemblies. You can bore for lifter bore bushings and move lifter bores around. It really just gave you the ability to machine blocks much faster. In the past, to do lifter bores, we had to send them out to somebody else, which takes a lot of time. You spend a lot of money in shipping. You can't make no money doing that. So.
My name is Brian Tell. Been a block machinist here at BES Racing Engines. Been here for about 6 years. Got about 10 years experience kind of in this background, machining away. This is probably a 2016, 2017 model LT4. Putting aftermarket dart and sleeves in it, the flange sleeve. Well, once these sleeves are out, because that's usually the hardest part is because I mean you're going from the roughly I think it's about 4055, 4060 bore. I don't really know what the standard bore size is. It's around there. Boring them out usually right now it's around 4-inch 240. That's when they start popping out. You know, the bad thing is since they're cast in, they want to break. Sometimes they'll break the cutters. You know, it's just there's nothing you can really do about it. But once they're all out, you know, they'll usually pop loose and spin. You can get them all out, as you can see here. I'll bore to, since the sleeve's 4300, I'm going to put about 2,000 press on them. Okay. So I'll get the bores finished, and then I will surface the decks. I usually do just a small cut on these LS's. I'll cut the counter bores and that's pretty much it for, yeah, often, I'll get it cleaned, I'll deburr it and stuff, but as far as that and the machine work, it's a done deal. It's ready to set these flange sleeves that we're going to use. So the sleeve that we're going to use in this is 4300 OD, so I'll bore these to about 4-inch 298. Oh yeah, this machine's great, man. I mean, doing it on like the old style, boring bars, I mean, it was really an all-day job. This is kind of knocks it down to, man, about 3.5 hours. And it's a done deal. I'm the dedicated block machinist guy, and before we'd all get a job, and from start it would be do our own thing, and then but now it's I do all the blocks, all the other guys. We got like 6 assembly guys, so I kind of keep them busy. And usually like these sleeve jobs, I kind of like them because the cycle time's a little longer, so I can have blocks honing. I got some lifter bushing jobs I got to do, and it makes it nice because it kind of does its own thing, and I ain't got to stand there and center up each hole because I've already probed this thing out and got it indicated in. It's just, you know what I mean? You can just walk away. Same deal with the hone down there with it goes from cylinder to cylinder. I mean, I can do 3 things, versus just, man, I'm boring a block right now. And being able to do, like I said, at least 2 simultaneously and going back and forth. I mean, sometimes, usually I'm just the 2, but if I got, something like if I'm sleeving this and I got, something, if I'm honing, 6-7 thousandths out, I can, line hone something, or, what I mean? So, yeah, it definitely increases the productivity, so.
Welcome back. We are now live. Myself, Joe Creason, Tim Eichhorn joining us virtually. We have sleeved the block. So informative. And this is just another example of how the technology has advanced so much. This is an area that enables a lot of possibility with these high horsepower engines. First of all, let's welcome Tim into the show. Tim, welcome. How are you doing today?
I'm doing great, guys. How you guys doing?
Excellent, excellent. We've just been having such a great time over the past 3 days. We're going to give everybody an opportunity to ask some questions of Tim on the subject. I see a couple of questions already populating, so put them in the chat section. We really appreciate that. Remember, all day long, we got heavy hitters here on day 3. But Tim, it has been so fun. Earlier in the week, Joe and I talking a little bit about building high-performance racing engines, and we just watched a video with you, and you know, the foundation of the racing engine is the block, and you just you gave us a little bit of an education. All right, let's get to the questions. First one, Chris wants to know about Loctite being applied to the cylinders for the sleeve install. Like, which is it? Loctite when you install the sleeve?
It's more of a sealer than more of a Loctite. So what it is it's a sealer-based red. I think it's Loctite. I don't have the specific number offhand, but it's basically a sealer. So what you want to do is, because these sleeves are doesn't have much of a press fit, is it actually you're using that Loctite / sealer to keep oil from coming up, into the cylinder being introduced, because the aluminum blocks will grow.
Excellent. And on that note, was the block in the video preheated? Chris has a question. Was that a preheated block?
We do heat our blocks just a little bit, just to make that installation a little bit easier, so we don't all that sleeve going into that aluminum finish. So we do heat up the blocks.
Excellent. Joe, dive in here a little bit in this. This is an area where you've got to get it right the first time.
You got one chance. You got to get it forward to the right size, the right slip fit or interference fit. And then when we do it, we always use the recommended sealer from what Darton, the sleeve manufacturer, recommends, and we have good luck with that.
Excellent. Tim, anything to add there, just in terms of, this is the ultimate measure twice, cut once kind of thing?
It is. I mean, basically, you want to make sure you sneak up on it when you're on the machine. You want that final cut is the final cut. You can't put it back in there.
Right. All right, Kenny wants to know, if you're chilling the sleeves to fit as well, how much of a worry is condensation being introduced?
In the past, we did use them. We use nitrogen, and we freeze the sleeves and everything else. And here in Florida, unfortunately, we do have a big condensation problem. So we did stop doing that. We no longer do that. Heating up the block and getting that bore precisely, to get that slight press fit has worked the best for us.
Excellent, excellent. Chris out there shouting out Rottler for his application. On aluminum blocks, what kind of press fit are you going with on the sleeves?
We usually shoot for 1.5.
What about you, Joe?
With the flange sleeve.
Yes, that sleeve, we would do the same thing. The Darton, some of their sleeves want less than that. We typically do it according to what they recommend for that particular application. Excellent,
excellent. Question more about the machinery. Is the Rottler CAM program available? Oh, getting a bunch of questions in all of a sudden. Is the Rottler CAM program available on the internet for download? We're waiting for our Rottler EM104, hopefully arriving this month. So it's good to see that they're excited about that. What do you guys know about the program and how to get it?
We don't know too much about it. I mean, basically when we got our machine, it was loaded with all the programs. But as far as Rottler's customer service, updating our programs, they have been great. We've never had an issue. Any little glitch on the machine, they're right on it and they get it fixed.
Excellent, excellent. Here's one from Dave. Years ago, we saw some sleeves at the trade shows that were put in on size with a special glue. I don't think I've heard anything more about that process. The idea that it distorted the block very little. So instead of using, I guess, that fit you were talking about, instead using a special glue. What about that, Joe, first?
Darton has some sleeves that are like that. They actually want a little bit of clearance and then glued in place. So we have used some of them sleeves that are like that, and they work well.
Tim, your thoughts?
The same thing, same what Joe said. Basically, I'm just going to repeat what he says. Darton does have some sleeves that don't want any press fit. They actually want a little bit clearance onto them. So you do have to use some kind of sealer. and that sealer glue type deal is to keep the oil from coming up through that sleeve and trying to, pressurize it.
Excellent. Joe is out there, so that will be 3 Joes involved in this segment now all of a sudden. Forgive me if this is a dumb question, but I haven't been in my dad's machine shop that much in the last 20 years. Shame. But if you have a customer's block, do you bore to a size, say 30 over, or do you just bore enough to make the cylinders round and match them to the largest bore? Asks Joe.
I don't quite understand that question.
Yeah.
Sure.
Tim, you picking up what he's putting down?
No, go ahead, Joe.
Do you bore to a size, say 30 over, or do you just bore enough to make the cylinders round and match them to the largest bore?
It would just depend on the mission. So if 30 over cleans up all the cylinders and a 30 over piston's available, that's what you would do, depending on what the customer wants.
Right, and how, well, exactly. This sounds like maybe more of a repair situation than building a high-performance racing engine.
Sure, in a repair, you would do, if it's a repair, you would, whatever the manufacturer offers for an oversized piston, you would go to that size.
Okay, next one. For your press fit, is that only on the main sleeve section or the sleeve flange also?
It's for both. You want to make sure that flange on the top actually has some kind of press fit as well. So, like earlier, it's basically a thou and a half up with the flange and the whole sleeve body in order to get that press fit.
Excellent. Got folks checking in from Denmark, so we're big across the pond. Thank you very much for logging on. And remember, you can watch everything that's happened the previous couple of days in our archive section. It's going to be great. This one coming in from Sammy. How thick should the bushing be at its very least? So wall thickness is the question from Sammy.
The actual sleeve itself, we don't like to see anything less in a high-performance engine than 125, which is basically 62 and a half per side is the minimum sleeve thickness that we like to keep on there to keep cylinder pressures and everything under that bait. Of course, the bigger the bigger you keep the smaller you keep the sleeve, the better you're going to have with that aluminum block distorting. So usually on some stuff, they have a max bore. So let's say on a Coyote motor, you have a standard bore of 3,630 and you have a max bore of 3,700. Well, that 3,700 bore is pretty much what that sleeve, the maximum thickness is in order to maintain that sleeve's rigidity. So, 62, 65 on each side. So it gives you about 130 wall. It's basically where we like to keep them.
Excellent. More questions, put them in the comments section, and we will get to them. Joe and Tim, I'd like to hear you guys talk a little bit about some of the challenges that pop up in this area. We've already kind of set the table for how vital and important it is. You only get one bite at the apple, number one. Number two, if a mistake is made, everything's got to come apart and you got to go back to work. So the time and efficiency is lost. So to make sure you don't run into those problems, what are some of the challenges you guys like to avoid? Tim?
Well, I mean, the biggest challenge, working in a machine shop and having, such heavy machinery and machinery that can basically, if something messes up, can totally ruin a block, is that, you just have to be careful. You have to keep your machines in top running order. You have to do the maintenance on them. You have to do the updates on them. You have to make sure your tooling's sharp and clean and new. So the biggest thing for us is to make sure that our cutters are there, that we don't have to have anything ordered, so we know when we get to a job that these cutters are fresh, this tool is fresh, the program is running, everything else. Every month or every month and a half, we actually just make sure the maintenance on the machine is right, all our points are where they need to be as far as tolerance goes, and then we'll run just a base program on a machine just to make sure everything's good before we go into a production mode. Because usually on a production mode, we usually do about 20 to 30 blocks in one run. We want to make sure they're quiet. So after about the 15th or 16th block, the guys will kind of stop and just make sure everything's running conditions and all the tooling's still good. So our biggest challenge is to make sure everything stays in the tolerance that it needs to be, is just to make sure that the tooling's sharp and new and fresh.
Excellent. We learned some of that yesterday. That was
Tooling's key. Sharp tooling yes, is key.
And good advice. All right, next one from Jason. Are you zeroing the flange to the deck or slightly above?
It depends on the application. If he's talking about leaving the sleeve proud, we do leave the sleeve proud on engines that are running like a copper type gasket that we know we can put a sealer on. But all our street type gaskets that run on MLS, we run the sleeves at 0 deck.
Okay. Kenny wants to know, when sleeving the taller deck height aftermarket blocks, do you have to worry about the block growth with the sleeves like you do with cam bearings?
No, the tooling keeps everything pretty cool. So basically nothing really moves. So what we do is when we machine the blocks, we actually will machine the block for the sleeves, remove the block, and then we actually will install the sleeves and then put it back. In that case, when we machine the block, we actually leave the sleeves about 10 proud in order to make sure that when we're cutting this thing, it's not too hot. When you do cut the aluminum, of course, the aluminum is going to get hot. But when you're just machining the sleeves and decking it, you don't have to worry about that heat growth.
All right, more questions coming in. What about sleeve hardness, says Alan? Diesel sleeves or compacted graphite. We're sleeving race blocks, and sometimes factory blocks get 8 sleeves. I like flanged sleeves, so you don't have a step at the bottom, and you can have a maximum cylinder length and piston support. What do you say about that?
Well, it's all into the design of the sleeves. Darton has really done a really good job of designing the sleeves for the Coyote. As far as hardness, man, you can't get any harder than the Darton stuff. I mean, it took us a long time to figure out even how to hone these cylinders. They're hard, they're tough, they're rigid, they're not going anywhere.
And isn't that part of what we've learned about throughout the week here, is that the technology of the machinery, but also the technology of the materials has advanced. I like the fact that you were challenged, Tim.
Yeah, no, it was definitely challenging. It's one of those things that once you get it right, then the next batch of sleeves come in, because they're constantly changing their stuff too. So we have to constantly change to their changing manufacturing tolerances, because it seems like one batch will be different from the other. So we kind of got to sneak into it from honing. And when we're machining the sleeve, we can kind of tell if it's a little harder, a little softer, or whatever else, just to do how the tooling wears on that sleeve as we're cutting it.
Joe, what do you have to add regarding that? Just the ever-changing evolution, like no two things. Everything has got its own personality, it seems like.
That is correct, and that's why you check every one or every batch that you do, and that's why when you hone these, you always check every one with a profilometer to achieve the right surface finish that you want.
Excellent. Chris wants to know, what's your finish process after sleeve installation? Thank you very much, Chris. Finish process. Tim.
After we sleeve them, we'll sleeve them. We'll put a torque plate on them, and then we stress relieve the blocks. Let them completely cool down. Usually what we do is we'll sleeve a batch of blocks during the day, and then the next day we'll finish machining them after they cool down. Basically, they go back on the machine. We bore them to within 8 thousandths the size. We'll deck them, and then pretty much they're ready for the home machine. And then we put them on the home machine. We put 2 torque plates on the aluminum blocks, one on each side for distortion purposes, and then we finish up to our surface finish that has worked for several years.
Excellent, excellent. Do you vibrate or stress relieve the LS blocks and other blocks? If so, what is the amplitude and frequency of the vibration that is used for various blocks?
It's kind of hard. I'm going to be honest. I've never really messed with the frequency of it. It pretty much worked what we have, so I haven't really much messed with it. I know a lot of guys will do it for different blocks, but the aluminum blocks is the only ones that we stress relieve, and we use the same frequency for each aluminum block, no matter what make or model it is.
Talk a little bit about that process for some of the folks like myself out there. What is the point of that?
It's basically, think of it as, I guess it's kind of hard to say, but basically think of it as when you're pouring concrete, you get air bubbles in there. So what you do is you have the vibrator thing, you stick it in there, and it kind of vibrates everything, kind of makes it to a point where it makes it flat again. So what we're doing is we're putting this block on a vibrating table. What it's doing is, it's called stress relief, and what it's doing is just moving everything and kind of just settling everything back in. So the sleeves and everything are just kind of moving down, and it's kind of getting rid of it, I guess, with so-called like an air bubble type deal in there, and it just kind of makes everything flat and eccentric. And it's just one of those things that there's really no science to it, except for, you know, it's I don't know, maybe Joe might be able to explain a little bit better than I could.
Joe?
Yeah, it's a black art. I can't explain it. I've just gone by what they recommended to do. We've done it, and it works, and so I don't know the frequency either. So.
I appreciate the concrete analogy as the son.
And that is correct. I mean, that's what you're trying to achieve. Yes.
Excellent. Just giving it a little bit of extra. Yeah, that was our. Let's see. Is the block bolted down to the vibration plate? There's one.
It is. It is bolted to it.
Okay. There you go. More questions, post them in the comments section. We've got just a couple of minutes remaining. Tim and Joe, digging deep on this. And Joe, do you got anything you want to bounce off of Tim or vice versa while we have this forum and we populate a couple more questions? This is an area that you mentioned. The whole thing seems like a black art to me.
The actual machining's not. You just have to measure twice and cut once, and comes from doing them, making mistakes, learning from your mistakes, and not making that mistake again. So it's really not a black art. The vibration deal is, you know, there's ultrasonic cleaning is a black art. I don't quite understand how that works. Similar process, it does. But
how long do you do? Dell follows up. How long does that process go on? Like if it's you know, black science a little bit, what duration? How long does that happen for? The stress relieving, Tim.
The stress relieving is only for about 10 minutes or so. It's not a long process. It's basically you just want to make sure that you put it on there, you know, and just go through that process. A lot of guys don't do it. They don't feel the need to it. We started doing it a couple years ago. We didn't do it in the past. I am going to say it's not 100% necessary to do it, but it is definitely that added step and the new technology that actually it gives you that extra confidence that you know you're giving that sleeve job the best quality job that you can, and you're giving that customer the best product you can.
Tim, any final thoughts? We're in our last minute or so. I really appreciate you dropping by and sharing a little bit of your knowledge. But now, you know, talk to the folks out there who are aspirational, building their client base, their machine shop. Obviously, there's more and more of these engines out there, and so there's going to be more and more work coming as people kind of move into high performance. Just take a moment or two to talk directly to them with some, you know, thoughts, advice, or inspiration.
Well, you know, the machine shop business is a tough business. You know, we all do this because we love engines in some sort of way. So there's a lot of ups and downs. You know, you got to take them with strides, and you got to take the ups and downs when you can. You know, the biggest thing is, you know, get with manufacturers that are going to stand behind your work. A lot of times you get a manufacturer that puts out a poor quality work and it makes your work look really bad. So you always want to make sure you use quality parts and stick with manufacturers that are going to stick with you. We chose Rottler because Rottler's customer service is great. Their machines are great. Their innovations are great. They keep up with today's technology. And that's the thing in key when you're in a machine shop. You know, the days of boring bars and you know, using a hand hone and all that kind of stuff, they're long gone. You can't do that anymore. You have to be precise, and you have to have the tooling that's going to make it precise. You want to make sure that you have the tooling and the manufacturers that are going to make sure that your name looks good out there in the industry.
Well, Tim, thank you very much. Great information. Really appreciate you and what you've done. Joe Creason as well. We're going to keep on rolling. Thank you for taking the time with us today.
No. Thank you, guys. I appreciate the expo. It was great, man. All the information is just overwhelming.
Awesome. Exactly. But the good news is everybody's going to be able to go back and watch it over and over again and hopefully reach out to you guys with any additional questions. Thank you so much. All right, everybody. What a day, what a day, what a day. My brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.